Hello, everyone. A very warm good evening to each and everyone who is present here today. Before starting, please let me know if I'm audible or not. Okay. Perfect. So, are you all excited on the same level as we are? Yes. Today is the fourth day of this particular Tech Edge Carnival, which we have hosted. You will be having three more sessions tomorrow onwards. You have already covered three sessions till yesterday, and today is your fourth session, right? I totally believe that most of you are very excited about not only the program which we launched yesterday, but also in general, the topics which we are covering on each day, every day in this 7 day carnival. Yes. So can you please all let me know how many of you are excited? You can type yes in the chat box. Are you excited, guys? Okay.
Vivek, you are on mute.
Okay. I'm really sorry. Perfect. Am I audible now?
Yes, Vivek.
Okay, perfect. So I can see that a lot of you are very excited. You're saying yes. And let me say, guys, that all of you are at least 90% ahead of your friends, your peers, because today you have decided to dedicate not only today but yesterday also you dedicated your Saturday evening and today your Sunday evening just for the sake of learning, right? And that alone shows your dedication. So how was the yesterday session, everyone? Did you like it? Did you enjoy it? Can you tell me in one word, what did you learn from the yesterday's session? Just in one word, tell me what did you learn in yesterday's session? Into the chat box. Okay, people here are saying cap. That was about the program which we introduced to all of you. A lot is coming about that as well. But in general, the session which was hosted by Mr. Varun Bhatt, what did you learn about that? Startup minds, application server. Okay, learned about tech. Okay, mindset, learned about coding, pedagogy, interesting. Startups, how to start up a startup, okay, coding, startup strategies. Great. Which means that a lot of you are paying attention to the sessions. That is important in the first place, right? I know a lot of you are expecting certificates for the same. All of you will be given certificates. Please do not worry about that. But that should remain your second priority. Okay. I understand that you are in an age wherein you'll have to, show the certificates, show the courses which you have done in order to get yourself good internships, get yourself good jobs. But at the same point of time, do not do not overshadow learning in that particular process. Thus, I would request each and every one of you to please be more focused towards what we are trying to teach you. Okay, you all will be getting certificates. Please do not worry about that. Today we are having a very special guest out here, someone whom not only me but my whole team at Masai recognize for his intelligence, for his vigor, and the way he teaches to students, right? Can anyone guess what would be today's topic? Come on, guys. I want each and every one of you to at least guess what would be today's topic. Can you guess it? Product-based Cosmos, internship, product-based companies, somewhat product management. Okay, internships. Okay, a lot of your ideas are hovering about network. Okay, someone here is saying API networking, how to make resume using Chat GPT. This is something which we covered already, Rahul, right? Can all of you tell me who covered this particular subject, how to make resume using Chat GPTs? Yes, Mr. Yogesh Bhatt. And I am very sure that a lot of you see of how many of you recognize him. Very nice. Okay, great. I'll not take much time, but I'll introduce the man of the hour, the person of the day who will be taking this particular session for the next good 40 to 50 minutes. Uh, okay, okay, perfect. So it is no one else than Mr. Sydney Rosario. He's a seasoned educator and a leader in the field of computer science. He's currently serving as the director of curriculum at Masai School. Sydney brings a wealth of knowledge and experience to the role, all thanks to his experience, which he had got through following things. So prior to joining Masai, he served as an adjunct faculty in the Department of IT at NIT K Surathkal, where they specialized in teaching data structures and algorithm. I'm not really sure how many of you by this particular time know what exactly DSA is. He taught DSA to both BTech and MTech students. Sydney's academic journey began with a BTech degree from IIT Bombay, one of the very premier institutions out there in our country, followed by a pursuit of higher education with a master's and PhD in computer science from the same institution. With a passion of teaching and a strong academic background, Sydney Rosario is dedicated to empowering students with the skills and knowledge necessary to excel in the world of technology. Sydney is right there in front of you, everyone, and handing over the mic and the stage to the man of the hour. Over to you, Sydney.
Thank you so much, Vivek. Thanks for the introduction. I hope I'm audible to everyone.
Yes, Sydney, perfect.
Okay. Good evening, everyone. Nice to see your excitement and energy. And I'm also very happy to be here to interact with you and share a few thoughts about today's topic on product-based companies. And since my area of study and expertise is data structures, algorithms, I'll tie that. I'll discuss something about these things also. So, hi, let's get started. Let me share my screen. I hope this is visible.
Yes, Sydney. Okay, perfect.
Okay.
Good to go.
Okay, great. Okay, so we'll be talking. Yes, we'll be talking about navigating the product company cosmos today, right? So what we'll talk about briefly are what product-based companies are, what do they look for in candidates. So if we are aspiring to work in a product-based company, what is it that we should keep in mind? How do we prepare? How do we get there, right? So, but maybe before we start going into the topic, I'd like to spend some time with you solving some puzzles. Do you enjoy puzzles? Yeah, no. Okay, a lot. Okay, good. Okay, good. Those of you who are enjoying it very much. All right. Let's solve a few ones. Okay. So the first one is find the odd one out. These three men who look identical. The second one, okay. Why is the second one? That's right. There's a watch, right? There's a small detail in the second one. His hand has a watch. Okay. This one is kind of maybe not too hard. All right. What about this? Can you find the mistake in the picture? Right. Yeah, good. You see that there is a signboard saying turn right, but on the picture, there's actually no right road going to the right? So yeah, good. All right. What about this? Can you find the mistake in this large, whatever, number? Right. Yeah. Took me some time initially, right? The spelling of the word mistake is wrong, right? It's written as mistake, right? But we tend to miss this many times. All right. What about this one? This one is probably a little more tricky. 2 clocks, yeah. So there are 2 clocks. Right. Yeah. Yeah, it looks like the sun is setting, right? It looks like it's the evening, but the clock is showing 2 o'clock, right? Yeah, the sun doesn't set at this time. All right. Okay, good. All right then. Yeah. Yeah, it's either 2 o'clock in the night or in the afternoon, but definitely not sunset time. All right. Okay, sure. Okay, let's start talking about product-based companies. So what do you understand by product-based companies? What does this mean? Product-based companies. Okay, Akshita is saying they offer products. So something like this, Lay's, Pepsi, Nestle, right? Yeah. Well, these could be called product-based companies, right? They do create these products, in this case, some food products, but that's right. We are talking about, well, this is, yeah, FCMG companies, but we are talking about particular in the field of IT, right? In terms of computing. So the companies that we are referring to, there are many examples, right? So I put up a few here. Oracle, Adobe, right? The big names, Microsoft, Facebook, Google, right? All these are, well-known companies. You must have heard of all, if not most of their names. And these are all product-based companies. Yeah, that's right. Yeah, Microsoft, Amazon, Apple. Yeah. So, so there are many product-based companies, right? But what do we mean by a product-based company in the field of IT? What is it? So I'm showing you an example of Microsoft, right? That's also a product-based company. So what is it that defines a product-based company? The apps they create. Yeah. Okay, good. Google. Yeah, Google is also a product-based company. What is it? Software products. The service they provide. Okay. Right. Cloud services. Right. Okay. Yeah. So, okay, good. So product-based companies in general, they create software products, right? And they sell them and make their money by selling these software-based products, right? So a company like Microsoft, it can have multiple products, right? Typically, you won't have just one product by a company. So Microsoft company here, in this picture, we are seeing it has its flagship, the product that drew the company for maybe decades was the Windows operating system, right? But now they have expanded to large varieties of other softwares, right? They have the Office applications, they have the search engine Bing, right? They have the Windows for different, for phones also, although that's now not very popular. But they have a constant series of products that they've kept building across time. Now in AI also, of course, right? Now the big name is, of course, ChatGPT that Microsoft has invested in, right? Okay, so what product-based companies basically they do, they build software products, right? They make their money by selling software-based products, right? So for example, Adobe has, its flagship of Photoshop product that it sells. Amazon, one of the main things, of course, it has is its e-commerce, the portal where we can buy, even sell things online. But that's not the only product, right? Yeah, Akash is saying AWS, right? So Amazon also has the AWS, the cloud-based services, which are also now a very important part of its products, right? What else, right? Google, of course, everybody knows Google's its main product with which it started was the search engine, right? It built its search engine so that users could quickly search results, and it was, it was really the revolution at the time it came, right? Just how ChatGPT is making the news now. At that time, Google was, the search product that it built, but it didn't just restrict itself to the search product. Google also has built a huge array of products, right? Through which it sells, it makes money through them, right? Yeah, Chandra, the latest one is Bard, right? Google Bard, right? Okay, so they build products, software product-based companies. Oftentimes, these products are scalable solutions, right? What do we mean by scalable solutions? They can be spread across to reach a wide variety of users, right? And thanks to the internet, this is, increasingly possible. So a company like Google, its search engine, initially probably restricted to a very small user base, but as people started seeing the phenomenal results it was giving, it just, expanded. And similarly, like nowadays, like ChatGPT, right? If after launching, there was so much demand for it that literally that they could not, serve the demand for some time and had to stop subscriptions for a bit, right? So a lot of these products, they are very built to scale, and product-based companies are constantly innovating, right? They don't just build one product and sit quietly, right? They have to constantly analyze the markets. They have to see what users like, what they don't like, and accordingly innovate and keep building new products, right? So good examples could be, as the internet started taking off, so companies like, let's say, streaming based companies like, let's say Spotify or Netflix, right? All of these started seeing that increasingly users are shifting away, right, from actual physical, let's say, music CDs, and they are, going to starting to stream music, stream movies online, right? So they built huge platforms and services to tap this market, right? Airbnb is another popular example where they figured out that people increasingly want to go to, remote, quiet places, have a unique experience while traveling. And so, they've set up this whole platform where, anybody, can rent out their, quiet spaces, their homes. They can put it up online, and people can easily search them and come and, stay in their places, which is very different experience from, let's say, staying in a hotel or a restaurant, right? Yeah. So they have to constantly innovate to stay relevant, right? And there's a huge emphasis on user experience in product-based companies, right? They have to attract and retain users, right? And when we talk about user experience, what is the company which comes to mind? What is one of the, right? Okay, Adobe, Apple. Okay, yeah. Well, good. I mean, these are all good examples. Google, yeah. Yeah. Google, Apple also, yeah, many people are saying Apple. For me also, I feel Apple is one of the companies that really does phenomenal work in, in building really attractive, intuitive user interfaces, right? And the products, right? Be it from the original iPods, the original products that they had to play music, then the iPhones, the Macs, and all. There is so much, emphasis on attracting users and keeping their user experience attractive and interesting. So these are some characteristics of product-based companies. Okay, and a common distinction is made between service-based companies and product-based companies, right? So service-based companies, examples here are given a few: Tata, TCS, Wipro, Accenture, and so on, right? There are many service-based companies, right? Infosys, of course, right? Yeah. So the difference between a service-based company and a product-based company is service-based companies typically they don't have, they don't build their own custom products, right? Yeah, Tech Mahindra, Deloitte, right? They provide IT services, right, to other clients, right? So let's say, for example, you have a bank, let's say the State Bank of India, SBI, right? And it requires a software to do its banking work, right? And so that software is probably built, maintained by these service-based companies, right? So maybe TCS will have a group of its workers who are entitled to, who are assigned to building it, maintaining the systems, make sure they run smoothly, right? And they don't have any issues with that, right? So the service-based companies, they typically have each of their clients have very specific requirements to which they deploy their employees to write very specific code for different clients. They don't have one single product that is sold to everybody, right? Unlike this product-based companies, right? And for us as aspiring job seekers, which one is out of product-based companies and service-based companies, which one do you think are many times preferred? Startups. Okay, good. Akash is saying startups. Yeah. Well, service-based companies, product-based companies. Yeah. So each have their, advantages, disadvantages. But purely from a point of view of, if you just look at in terms of remuneration, right, in terms of salary, it oftentimes tend to be that product-based companies tend to remunerate more, right? Their salaries tend to be high. They have, lot of innovation happening, and so many times, there's a lot of learning, a lot of opportunities for growth. Product-based companies are definitely, for many of us, it's a really a dream to get placed in product-based companies, right? So the whole question is, right, how do we get placed? What do these product-based companies look for, right? If I'm a job aspiring job seeker, if I'd like to get placed in a product-based company, what is it that I should be having to be placed in a product-based company? Skills with good knowledge. Yeah. Okay. TSA, coding, communications, certifications, marketing skills, hands-on project. Good. Yeah. Good. Experience, skills, communication. All right. Okay. Good. I think you've I think covered all the points. So soft skill. Okay, good. Yeah. All good points. Right. So if we look at the hiring process in product-based companies, first thing they do is shortlist resumes. We have already seen with Yogesh sir how we can build attractive resumes. That is really the first step. And once if we have cleared the step, then typically we have coding rounds, right, where we are given some problems. So many of you have said DSA, right, data structures and algorithms. There we have to maybe we are given a task, a problem, and a fixed amount of time, and we have to solve that particular problem in that given time correctly, right? And once maybe that is passed, we might have multiple rounds of technical interviews, right, where you're quizzed on different things, different your understandings of maybe data structures, algorithms, but general programming languages. These things are tested. You may be asked about your projects, right? What kind of projects, practical works have you done, right? All these kinds of things come in the technical interviews, which there may be multiple rounds, right? So some of the big companies, product-based companies, have a series of technical rounds before finally offering the job, right? Right. So what oftentimes what are they testing in these coding rounds? They are testing really the primary skills that they're looking for is problem solving, right? They really want to know how good we are with solving problems that are given to us, right? Sometimes known as critical thinking also, right? Given a problem, how well can we try to look at it? How can we approach it? Can we approach it from different angles? Can we, so to say, think out of the box, right, to solve a problem, right? So this problem solving, this critical thinking is really the main skill that product-based companies are looking for when they want to hire us, right? And one of the ways, the main ways that this is tested is using DSAs. That's right. Yeah. So data structures and algorithms. This is one of the main ways companies use to test our skills to solve problems, right? So they'll expect us to know the basic data structures, so the different arrays, tags, queues, right? And many more algorithms, right? So all these things are we are expected to know and know well, right? Yeah, loops, please. Right. Yeah. And of course, we're expected to have good coding skills, right? It could be in any programming language, it can be in C++, maybe Java, JavaScript, Python, right? So given a problem, we should not only be able to explain it in words, but also be able to actually code it, write a code for it, solve it, and produce the results, right? So of course, all this, some of you also mentioned communication, right? Communication skills are also very important, right? It's actually crucial, right? In interviews, if you are not able to communicate your ideas, communicate how you are approaching your approach to solve the problem, then it is a serious handicap, right? We should be able to articulate and share our thoughts, share our ideas clearly with the interviewer, right? So that's a huge skill, right? So, yeah. So data structures and algorithms, these basically, they are all about, I would say, problem solving, right? They are, so somebody is asking how much, can you tell us more about critical thinking and problem solving? This, it's nothing, it's something that we learn, by, I would say a lot of it also comes by practice, right? Especially in data structures and algorithms. Initially, a lot of things might seem very difficult, but when we start learning, we start getting exposed to new methods, to new patterns, right? To new algorithms, we suddenly start to feel confident. We start to get more tools, right? To solve problems, to think critically, right? So, right. So I'll talk briefly about data structures and algorithms, just to give you a flavor of, what all of this entails, and before moving on, right? So essentially, whenever we think about, solving a problem using a computer, right, there is it involves some kind of data, right? So the data can be of various types, right? So, for example, over here, I've said, let's say financial, right? So maybe you have the prices of stocks in the stock market, right? And you want to do some analysis on that, right? You want to maybe observe market trends, maybe predict what the future might be, right? So there is all this data around financial information, right? maybe it's cultural data of cultural, I don't know, it could be, let's say, books, right? Or it could be movies, right? Or songs, right? There could be scientific data, which is, data which is important in the field of medicines, right? Medical research, there's a lot of data, or here they're saying meteorological data, transport data. So whatever problem we are trying to solve using computers, it involves some kind of data, right? And when we want to solve that problem, we have to store it in some way, right? And that is what data structures essentially are, right? It's telling us how do we store this data structure in the computer. Akash saying like jar in the kitchen. I think, yeah, this example was shared to you in one of the previous sessions. That's right. It's basically how do we store all these data in our systems, right? And that is essentially what data structures are. And what is the algorithms is basically how do we process this data, right? Once we have stored this data, we have made a decision of how to store this data, then we need to process it. We need to do some computation to get some output, right? And that is what algorithms essentially are. Okay, so we'll briefly talk about these two topics. Data structures, so you've seen the jar example. Another, common example that is given in data structures, you can think of it as these shopping carts, right? So let's say I go to a supermarket and I want to buy some products, right? If I just go and I just want to buy just, one, let's say just one toothbrush, then, it's just one product that I need to buy. I can just probably pick it in my hand, just walk to the counter and buy my product, right? So in that case, maybe you could say the data structure is your hand, right? You're just using your hand to hold that product, right? But let's say now that you want to buy more than one things, right? You want to buy your toothpaste, some soap, and also some rice, right? Some bread. There are some 4-5 items, right? So then maybe holding everything in your hands and walking around might become a bit difficult. So you pick a different container, right? A different data structure for this particular scenario. Maybe you'll pick the cart on the left where, it has a nice handle. You can put in all your 4-5 items and, comfortably walk around and do your shopping, right? But now let's say your problem was slightly different. Your scenario was slightly different. While you're shopping, maybe somebody from home called you and said, can you also bring I don't know, 10 kilos of atta, right? Now, when you have to carry 10 kilos around in your supermarket, maybe you will choose not to hold this have this carriage where you carry it all around. You might get tired. So maybe you'll pick a container which has wheels, right? You can put those items in that container and take it around. You can solve this problem rather comfortably, right? So in this particular scenario, a different structure is useful to do our shopping, right? You get the idea, right? So depending on what we are doing, we have different, so to say, containers that are useful, right? So there is no one single data structure that is that solves all the problem that's useful for all scenarios, right? It really depends on the problem that we are solving, right? So right. So I'll give you a simple example of stacks, right? Some of you are already saying stacks, queues, objects, right? Is everybody familiar with stacks? How many of you know about these? Stacks, yeah, right. Stack of books here. Yeah. Okay, good. So, all right. Don't know. Yeah, don't worry. I'm not expecting, really, I'm expecting that you do not know all of this. I'm just to give you a flavor. If you're not understanding much of it, don't worry. It's just to give you a flavor of what these things are, how they are relevant, right? Yeah. So, stacks are basically, structures where you put items one over the other, right? So the picture here, you have one over the other, the books that are kept one over the other, right? Or you have these picture of dosas, right, which are piled one over the other, right? And yeah, many of you are very familiar, I think, with stacks. You all are saying last in, first out, last in, first out, LIFO. So one of the main properties of these stacks is that the last item, the items are only put one over the other. So the last item, the item that goes on the top, is basically the first one that you access, that you remove, right? So when you have these stacks of dosas, you might pick the top one, right? The one which is the hottest. You'll pick it first, and then you'll pick the next top one, and the one after that, and so on, right? So this is how stacks work, right? So stacks are typically shown like this. You have an empty stack, and then when you add an item, initially you add some item one, you put it onto the stack, right? So one gets pushed onto the stack. Then you have another item, right? Two, which gets pushed onto the stack. So it comes on top of the previous item, right? Then you might add another item, the third item, that comes on top of the previous top. So three is the third item. Two was the previous one. So three comes over two, right? And so on. And now when you have to remove items from the queue, you're only allowed, from the stack, I'm sorry, you're only allowed to remove the items which is at the top, right? You cannot go and pick an item in middle, right? So the first one I remove, this operation is known as a pop operation. When I do this pop operation, the first item to get removed is the top of the stack, right? So this three gets popped out. And then once three is gone, then two, this stack reverts to this state where two is the top element. And then if we again do a remove operation, the element two gets out of the stack, right? So if I share with you a common application of stacks is our web browsers, right? So if we are browsing a series of web pages, so we start, let's say, with Google, and then let's say I search on Google, I search for whatever, Amazon, right? I go to Amazon, so I'll say Amazon, right? And it goes to, right? It goes to this page, Amazon, right? Then I don't know, I say Facebook, right? This is showing a page of Facebook. I don't know why it's showing it here in Kannada, right? And whatever, right? Then I go to, let's say, Apple, right? I go to the page Apple. Yeah, good. So now, when you do this small back button over here, right? When I press this back button here, you see that it is showing me the list of web pages that I have visited in the order, but not really in the order, in the reverse order, right? The first time I press a back, I go to the previous page, which was Facebook, right? The next time I again press a back, it will take me to the page before Facebook that I was on, which is Amazon, right? If I do one more back, it will take me to the page I started from, right? Google, right? So our web browser here, in this case, Chrome, right? It is Safari. It is maintaining the list of web pages I visited. And whenever I say back, it is taking me to the correct web page, right? And this is basically done using stacks, right? This behavior is implemented by stacks, right? So the application, this is one of the most commonly cited applications of stacks, where the web pages, right? Here I've shown a picture, here Google, then some other website, then maybe YouTube, right? They are all stored, we say they are pushed onto the stack, right? Whenever I visit a new web page, it is pushed onto the stack. So it sits on top of the previous web page, right? Each web page I visit similarly gets stacked on top. And when I hit a back button, what the web browser is doing behind the scenes, it is simply, going to that stack and removing the top element, right? It's popping out the stack, and whatever is now the top of the stack, that was the previous website I was on, right? So this behavior of, this back behavior of, these web browsers can be implemented using stacks. Okay, of course, that's not the only use of stacks. Stacks have multiple different applications, but we'll just talk, keep this simple one here. Okay, what about algorithms, right? We'll very quickly talk about algorithms. Data structures is how the data is stored. Algorithms is how it is processed, how we do the computation to get some results, right? So the algorithms, we usually talk, like this picture where you think of algorithms as a sequence of steps, right? You do step 1, step 2, step 3, step 4, step 5, right? In this case, there is an algorithm how to make tea, right? You bring some water to boil, then add some tea leaves, add some sugar, right? Add some milk, heat it for some time, and finally you have your nice hot cup of chai, right? So algorithms are typically expressed in these manner, where a series of instructions which are given to the computer to process the data to get the output that you want, right? So a common example is something you might all have used in life, right? Google Maps, right? So a product of the Google company, where you want to go from one place to another, right? And you give it this, maybe your current location and the destination that you have to go, that you want to go there, right? And Google is able to find out, it has a navigation algorithm that will tell you what is the quickest way to go from your current location to your destination, right? And these can be very sophisticated algorithms, right? Over here, it's showing you how, it's telling you the approximate time, it's telling you where the traffic is, heavy, and things like this. It's suggesting alternate routes, right? So all these are behind the scenes. We have algorithms, right? There is some data. Google is storing the data, the roads, which are all the roads, what is your destination, what is your current location. All these are data which is stored at Google, and this data is processed by an algorithm to give you output, something like this, right? I'll skip this particular example. When we talk about algorithms, another feature that is often asked in algorithms in interviews for product-based companies is the efficiencies, right? So given an algorithm, how good is it, right? How well does it do its job? Can you do better, right? So as an example here, if you want to search for some word, right, in an English dictionary, you have to search for a word. Let's say search the word S. Actually, you have to search for the word S. Then naturally, one way to do it is you start from the first page and you keep, scan word by word, go to the next page, scan word by word, and until you find the word you're looking for, right? But none of us in our right minds will do this, right? What we'll do is we might simply go and just open some arbitrary page in the dictionary, right? And then we will look at where we are. Let's say we opened a page where all the words are starting with the letter P, right? And then what we are doing internally, we are running an algorithm, right? Our minds is saying, okay, we are on the page P, but I want to go to the word search, right? S, which starts with S, right? And P comes before S, so I need to go further ahead in my dictionary, right? I need to look further ahead, right? So we are running an algorithm in our mind, right? We have a logic, right? A series of steps to solve this problem, right? And this algorithm, right, where we are searching is definitely better. It's more efficient than the algorithm where we are just going page after page, one after the other, look through the words, right? So when we talk about algorithms, we have algorithms, we can have multiple algorithms to solve problems, but what we look for, especially in our interviews for product-based companies, they will ask us, it's not only sometimes sufficient to give any algorithm to solve a problem, but we should also know which is a good algorithm, right? Which is an optimized algorithm. So oftentimes the interviewer will ask us, what is an optimal algorithm to solve this problem? And that is something we should be, we should be aware of. Okay. All right. More puzzles. I don't know if we have much time for this. Maybe shall we do 1 or 2 more puzzles? We're getting close to 9. All right. Okay. All right. Okay. A lot of yeses. All right. Okay. More problem solvings, right? Okay. All right. What do you think is wrong here? Min and max, right? They are misplaced, right? The min is on top, max is. All right. What about this one? When is L greater than XL? XL is always greater than L, right? Yeah. It's not possible. Not possible. XL is always greater than L. Okay, good. Yeah, some of you have got the answer. Right. It's in the Roman numeral system. Okay, long time ago, you might have studied the Roman numeral system where the letter L stands for 50, right? And XL is basically 10 before 50, right? 14, right? So this is an example where you have to slightly think differently, right? I'll skip this one. Let's see if you can figure this one out, right? You have given all these stars and you have to just use 4 lines, right? You have to use 4 straight lines and you should not lift your hand. So imagine you have a pen or a pencil and you have to cover all these stars using just 4 lines, right? Without lifting a hand. Okay, that's the key. Only 4 straight lines. Like 6. Well, if you write like 6, you do 1 line. Then when you go down, that's the second line. When you go to the right, it's the third line. 4, 5. You'll need 5 lines. Right? If you draw a square, then you have 4 lines, but the star in the middle is missed. By making 5. If you make a number like 5, 1, 2, 3, 4, 5. Right? That's again 5 lines. Same with 2. Okay. Yeah, this one is tricky. Right? So literally this answer requires you to think out of the box. Okay. So the answer is something like this. Okay, there may be different ones, but here, right? The problem never said that you cannot go out of these stars, right? The problem was that you have to connect all these stars with lines, right? With 4 lines without lifting your hand, right? And literally you have to go out of these boxes here, right? You have to think out of what our natural way of thinking is, right? So this is an example of maybe thinking out of the box, right? So yeah, these are kind of skills that we have to develop, right? We have to learn to cultivate in order to do well in these interviews, right? G-type also, yeah. There'll be different patterns, something like this. Symmetrically, you might have many patterns, but the main idea is this. All right, okay. I want to spend the rest of this time together just going about why Masai, right? If we want to join product-based companies, why should we be at Masai? Why should we join Masai, right? If we are all in colleges, isn't a college degree enough, right? If we just go through our colleges, complete our graduations, why can't we get just placed? You think college education is enough to get a job? Not at all. Okay, Akshita is saying no. Okay, some of you are saying yes. Surya Kama, no. Okay. Depends. No. Yeah. Okay, that's right. Unfortunately, the answer in India for in general, the answer for a large number of colleges in India, it's generally the answer is no. Right. So I'll talk about different parts why Masai is relevant, why it is important. The first one that I'll emphasize is strong curriculum, right? So typically in colleges, you may have, I've heard so many stories of people who have had a college degree in computer science or whatever, maybe a BCA also, but have never really written a computer program, right? There are a lot of books, they have studied a lot, they know all the definitions, and but when it actually comes to programming, they do not have a lot of knowledge, right? Or you may say that even if I have not done programming, I can just, I can just go to the web. There are so many, tutorials online. There's YouTube. There are so many videos. There are so many articles. There are so many blog posts. I can just, go through them and develop my skills. Okay. Well, in general, I would say there is so much information out there. It's just overwhelming sometimes, right? And you are totally unsure. I'm seeing some of the comments also, some of you asking, is this, is this book good? Is that book good? Is this site good? Is that video good? Right? So there's a lot of information there, and it's really hard at times to really know which is good and what is good, because sometimes something that might seem good is actually, I've seen many times that it's even incorrect, right? So what Masai really offers is a way out of all this confusion, right? It is shows us a clear pathway to develop our skills, right? Our problem solving skills, our coding skills, even our communication skills, right? The curriculum in Masai is really, thought about deeply. It is designed well such that we take step by step, right? We go step by step, each step learning more, growing our knowledge, growing our skills, and becoming, closer, getting closer to our goal, right? Which is to whatever, become a software developer, right? And these steps are very clearly defined, right? If you just go to a website and you randomly pick a problem and try to solve it, you might just get stuck. You might find it too difficult, and then you might just think, oh, this is too difficult, right? But in Masai, like if you, or let's say you want to, build, lift weights, right? You go to a gym and you immediately try to pick, let's say 100 kilo weights. Maybe you'll, break your back or something, right? So the journey in Masai, that is the curriculum, is really thought about such that we learn gradually, right? We learn in the right way, and it is challenging. It's not easy, but we are constantly growing in the right direction towards our goal, right? That is one main thing. Daily practice is another huge part of our curriculum in Masai, right? Let's say you want to learn to cycle, to ride a cycle. You go to libraries, you read all the books about cycling, you go to YouTube, you learn all the theory, right? And you've mastered everything. Do you think you will be able to cycle? Clearly, no, right? That's right. Right? The only way to learn to cycle is by doing it, right? By actually doing the cycling, right? And the same thing is, of course, for programming, right? No matter how many YouTube videos you might watch, no matter how many different books you might read, right? Ultimately, we have to get down and practice, right? And we have to practice every day. Like, supposing you want to learn cycling, let's say you pick up a cycle, you ride for 5 minutes, and then you come back after 1 week and you say, okay, let me try again. And you pick up and you ride for 5 minutes. And then after one more week, you come back. Do you think you'll ever learn how to cycle? Right? No, the practice has to be consistent, right? Our daily practice, this is something we constantly do at Masai, right? We are daily practicing to code. It's a daily ritual. Every day we are trying to code, and that is how we start getting better and quicker, and faster, right? And by the end of our program, we amaze ourselves, we surprise ourselves how good we have grown, right? Himlata is saying sometimes we'll fall down, of course, right? While riding a cycle, sometimes you're going to fall down. And that's the beauty in Masai, right? As opposed to being by yourself, right? If you fell down by yourself, maybe you don't even know why you fell down. You just, I just fell down, right? But in Masai, if you get stuck, right? If you're stuck with solving a problem, there are different ways to which, we can help you to address that. Right? You might have mentors who can see exactly where you're stuck. You can share your problems with them and they might guide you. They might tell you, this is what you're doing correct, but this may be somewhere where you are making, there's something that you can improve on. You're making a mistake here, right? And that gives you the insight, right? To learn from that, to not make those mistakes again, right? If you're learning to cycle, maybe you're constantly doing something, you're sitting, you're tilting to one side. So if somebody points out, right, this is the mistake you're doing, and then that really helps us avoid them to grow and learn our skills, right? So the same things here in Masai, our daily practice, but we also have constant feedbacks where we can grow, right? Okay. Regular tests. Okay, so we have time programming contests, right? So we have where we are regularly simulating how it is to be in a product-based company interview, right? So when you have a coding round in a product-based company, you will have a programming task that is given to you, and you have to write it in, let's say, finish the job in 1 hour, right? And what we constantly do here is we keep giving time programming contests. So they're basically giving you practice for the final, your interviews, right? So you're constantly doing this such that you gain practice and it becomes more and more natural to you, right? So you get better at these things. And not only writing code, many times you could also have some kind of interviews where you are talking to people and like simulating an interview, right? You have asked live questions, and that also can give you feedback on how to communicate better, how to explain your ideas better, and do better in interviews, right? So there are the placements is another important part, right? That we have. You build your skills and you go through interviews to get this jobs that you get, right? There are a lot of hiring partners that placements come, and that come to the placements at Masai. And so that is also something that is really strong there. Okay, I can encourage you to go through these different testimonies of people who are gone through the program and done very well. Okay. Yeah. All right. I see that you have a lot of questions. When is the new batch? When is going to come, and things like this. So this will all be shared and discussed by the panelists. And yeah. Yes, that's all I had to share for today. Yes, it is 9. So thank you all for being part of this session. And yeah, let me stop sharing my screen and go back.
So guys, how do you like the session? How was Sydney? Let us know in the comments. Great. Thank you, sir. Very nice. Excellent, sir. So that is just like in the last photo, you are seeing the quality of the instructors that Masai offers. And one student was asking, that is why I came to answer that question. That what does Masai offer extra that other courses are not offering? This answer you have to figure it out actually. I'm not going to tell what we are going to offer you extra or less. This is like, you should understand this part. We are here to push you towards software development. We are encouraging you that you should go and you need to try something extra. If you want to become a software developer, your college journey is not enough. And after that, it's you who have to figure it out. Sir, do I have to go to YouTube and learn? Do I ask my senior to learn? Do I have to go to Masai to learn, or any other website or any other thing? But this is your work to do. Our work is only to aware you and just come up with something innovative and exciting things for you that will help you in learning and progress, and maybe one day you will complete your dreams, right? But all you need is a little push. Without that, guys, I'm like, I have mentored more than 60,000 students in my journey. And so that all these people, what we can say is, the kind of experience we have right now versus the kind of experience we have in the college is very different. And now we realize, and we want you guys to realize, that college journey is not enough. College education is not enough. You need to upskill yourself if you want to progress. With that, Sydney, I request you, can you please turn on the camera? I need to take one picture, which I'll post on LinkedIn. And yesterday I couldn't do it because my phone was switched off. But guys, today I'll post it and post the link. After that, Vivek will take over. We'll take your Q&A. We'll give the quiz link and we will end the session. So give me 1 second. Can you ping? Okay. Can you ping Sydney? Yes.
Done.
Okay, thank you so much. Vivek, you can take it over, guys. Whatever questions you are having, ask them, and then we will share the quiz link and LinkedIn post link. Over to you, Vivek.
Perfect. Thank you so much, Aman. Thank you so much, Sydney, for a wonderful session, actually. Not only with the students, even I was engaged in this particular session, solving the quizzes which you were giving us, solving the problem statements which you were giving us all the way through. Perfect. Now that the daily ritual has done, which is Aman taking a good selfie and posting it on LinkedIn, and all of you engaging to that particular post, let us start with another exciting part of every day's TechEdge program out here. So I'll be posting the quiz link in the chat box. I would request each and every one, not only just few sets of people, but each and every one to at least try the quiz once. Does not matter if you did not attend the quiz yesterday, does not matter if you did not attempt the quiz so far, even once, okay? Do not procrastinate, try attempting the quiz now. Try attempting the quiz today, okay? Perfect. So I have posted the quiz link in the chat box. I would request each and everyone will be giving you 2 to 3 minutes to register your responses, and then we'll be starting with the much awaited Q&A. I know it's Saturday evening, everyone, and I know I really salute your dedication to join this particular event, to join this particular connect, which is brought by Repleaf by Masai, named as TechEdge. And this is really appreciated not only by me, but all the stakeholders. And actually, this shows the dedication each and every one of you is coming forward with, right? Do not worry. We promise that we will definitely be making some kind of change in you with respect to when you came on the very first day. Okay, perfect. So I hope that a lot of you have already started attempting the quiz. But for people who still are not really sure what to do, I'm again sending all of you a link in the chat box. I would request each and every one of you to kindly click onto that link and then submit your answers for the 5 questions which we are having. Okay. For people, okay, someone here is asking, can you share the link once again? There it is. For students who are asking that, Vivek, can you please tell me what exactly is this activity? This is a very normal activity, a very kind of engaging activity in which we give 5 questions at the end of the session every day. And we'll be doing this for the next upcoming 3 days, which are left, removing today. And after that, there is a leaderboard which is made. Okay. And the leaderboard, everyone can see their respective names. We've been showing the leaderboard to each and every one of you from the past 3 days. And I would request only once all of you go through this particular quiz, only then it will become beneficial for you, and I think you will be happy to see your name in the leaderboard too. Okay, I've again shared the quiz link. Perfect. So I think now it's the time for me to take few questions, few of your important questions, few of your concerns regarding the topic which we covered today by Mr. Sydney. So if anyone of you wants to ask something to Sydney, if you want to ask any kind of question to Sydney regarding what he covered today, please feel free to let us know in the chat box. I'll pick your questions one by one, okay? So Sydney, there's a question coming in. I think people are quite curious about DSA, in general, DSA, data structures and algorithm. There are 2 questions actually. The first question is, what if I'm not good in DSA? Now, this is coming from a person who might be well aligned with this particular domain, right? Another set of question is coming from students who were not really aware about anything called as DSA until you took their session, or let's say that 2 days back, Aman watched